Alright, welcome back. So we're about halfway through this Module 5 set of lectures. Now, take a little break in between going through the statistics and introduce this Module 5 assignment, the third notebook that's dealing with statistics and probabilities. And we'll go kind of run through this. We've got the goals of this notebook, and we want to transition from data analytics to basic statistical analysis, not the descriptive stats that we had before, the low level stats. We're digging deeper into a statistical analysis. We want to expand upon the prior experience that we've had manipulating, summarizing, and visualizing small data sets. And we want to practice the computation and display of summary statistics, the percentiles, the PMFs, and CDFs. So we're going to use swarm plots, box and whisker plots. There's a variety of different visualization tools that we're going to deal with. Use pairwise correlations. And we're going to practice computation displaying representative statistical distributions. So we'll look at skewness measures, and we're going to estimate parameters of distribution and propose a model that explains the underlying data. What model is going to work for us? All right, so with that said, let me go ahead and pop this open in a new window. And let's go look at it. So here we are. It's a starter file for assignment 3. Go save a copy, put your name on it, fill your data in here like you've done in the first two, and we just went through what are the goals of this notebook, the instructions. You've got your PDF, your iPy notebook file, a link to your Colab. So, as always, don't overdo it. So we start out with the imports in Google Drive. So here's our basic, what do we need to do? Okay. So we go through and we're going to get a data set. Now, the data set we're going to deal with in this one is the IRIS data set. And here's a link to get more information about it. So you want the code book for it, you go dig in here and you'll see it. So we brought in NumPy, PyPlot, Seaborn, things that we've dealt with already. We load the data set, store it in a data frame called IRIS. We look at the head of it. You see the indices for each row. There's sepal length feature, sepal width, petal length, petal width, and the classification, the known classification for a given flower. So these are all types of irises. They measure different attributes, the 4 different attributes of the flowers, collected the data, and then included the classification for species. Now, what can we say about the data as we glance at it? It's numeric. We can work with this. How about the classification? Not numeric. So we may need to clean this up and convert it to categorical, but we'll deal with that a little bit further. We look at the shape of the data set. 150 rows, 5 columns. 1, 2, 3, 4. And the class is the 5th. So those 4 are the important ones for now. That 5th one is important. How many unique species do we have? 3. Okay. Let's go look at it and see what we're dealing with. Species equals versicolor. Show me what's going on. Let's go analyze the petal length. I can visualize that data. Your task now is to modify this histogram. You've got the code to do it. using the square root rule for the number of bins. And 2 points associated with that. Describe what the square root rule is. You're going to modify the histogram such that the y-axis shows probability to proportion rather than absolute count. We'll talk about proper PMF. Then you're going to compute the summary statistics. 1 point for each. So you've got the mean and the standard deviation. Okay. 1, 2 points, 4 points, 6 points in all. Okay. Add in multiple code blocks as needed. I'm going to go through, and now it's going to be your turn to make a bee swarm plot for the iris petal lengths. Each one of the 3 classifications, what's the distribution for them? And we see that we've got logical groupings that, depending on the class, you are within different ranges. Now, some of them overlap here between versicolor and virginica. But if it's way down here, odds are it's going to be setosa, because none of the others, if we wanted to go predict, none of the others fall within this range. Okay. To go through, write your code to display this bee swarm plot. I'm going to go through and do empirical cumulative distribution function. There's a code to do it. And you're going to go through and do it to where your results look like this for our given data set. Okay. You can use this function to do what we need to do. Okay. From there, you're going to go ahead and do the same sort of thing, but it's for the petal lengths of all 3 iris species. So we can visualize all 3 of them on one plot. We're going to go deal with the percentiles and see where we are. And we see the different percentiles. Write code to compute the 25th, 50th, 75th percentiles for the petal lengths, and plot the resulting values overlaid with a corresponding ECDFs of all 3 iris species. Okay. This one is for versicolor. This is supposed to be for all 3 on this your turn. And we'll deal with the box and whisker plots. On the box and whisker plots, we saw this example in the text. You're going to go through and do yours, and it should appear like this. Now, I'm going to pause a second before we move forward anymore. We mentioned this back in the first 2 assignments. Code is already out there available to you. Use it for inspiration, not to replace you actually doing the work. Okay. You can go through and do it yourself, and then go look what others have done and say, hey, how's it compared to what I did? Wow, I didn't think about doing it that way. Theirs looks better than mine. Try to keep it simple and do, if this is all we need to do for this, then make it look exactly like this. So when you run into things that, well, I'm not too sure on this, it's out there. There are thousands of notebooks on the internet associated with data analytics, data science, and the iris data set. One of the most widely used low-level small data set for teaching data science is the iris data set. Okay, so we're not recreating the wheel. It's a data set that's widely used. You'll see code out there that will help you get where you need to be. Play with it, see how different changes do the different things when it comes to visualizing it. Got some bonus points. Write code to display the box and whisker plot combined with the bee swarm plot for petal lengths of all 3 iris species. So then we've got scatter plots, pair plots, and the correlations between the different variables. So here we go, where we're looking at everything and how it's all plotted out. And we compare the 3 different classes and how things plot relative to sepal length, sepal width, and correlations between them. Here's some bonus points. Expand on this code up here to compute the Pearson correlation coefficients for all pairwise combinations of all 3 iris species and display the results in a table format. So part 2 will deal with empirical distributions and analytics distributions. So we've got representative analytic distributions, and here we look at the PDF and the CDF. Got code that will run, and you can see how it all plays out. And then you're going to write code that will plot the PDF and the CDF, right, for each. From there, we're going to do some model empirical distributions with the analytic distributions, and we're going to look at the Belmont stakes results. Okay. So we've got an array relative to Belmont stakes, and go through and we'll compute the ECDF. And then here it is plotted. Okay, so we've got that. Some bonus points. Try to answer the following question. Okay, so this is something, if you want to go down this road, there's some bonus points there. Do this after you've got the other points knocked out. So this next task is we're going to investigate whether the speed of light measurement by Michelson are normally distributed. All right. And it has to do with a rotating mirror experiment. So here's a link that explains it. So we've got a data set, and I've got a link here to the CSV file if that's needed. I've got a link here, rather than you having to put it over in your G drive, I've got it coming right off of my GitHub repo. I'm starting to see why we're using GitHub repos. Great way to store and save shared data. So I've got a CSV. You can connect to it. Let's go look at the head. So we see what's going on in the data. Now let's look at events over time. I'm going to go look at births. All right. So go pull in another data set. Hang on a second, let me pop back up here. This pulled the data in. I didn't dig into this quite deep enough. This pulled the data in for you, and I showed you the head. You need to compute the mean and standard deviation from this. Take 10,000 samples out of normal distribution with this mean and standard deviation. You're going to use a NumPy function, random normal. Then you compute the CDF. So you had here ECDF. I want you to go through and do ECDF for this. Okay. Now, on this next one, we're looking at births from Brisbane, Australia over time. And with this one, you're going to read the data in, and it's like, well, where's this data coming from? Click here. Here's the CSV. There's the path. All right. If that's the path, see what we did up here. Do what we did here. You're going to do it here, but instead of using this path, you're going to use this path. Okay. Now, one of the things you're going to see different right here, notice the word raw. It's raw data. We come look here, see the path and it says blob. What you're going to do is use this path, but you're going to change it from blob to raw. So that's what you're going to need to do here to be able to access that data. Test it. Go look at the head just like we did here to make sure you're accessing the data and it's coming through. Okay. So you're getting used to connecting to data sources, performing these statistical analyses on them. You're going to go through, do similar to what you did up above. You're going to do it here for Brisbane. Okay. Then we're going to look at moments and skewness. We talked about this later on in the what would be the second lecture, or the second actual lecture. This is a lecture, but it's just a walkthrough on this assignment. So the second module 5 lecture, we're talking about statistics. Okay. We talk about moments and skewness. We've already talked about skewness to a degree, but not to this point. So here's a path to the salary CSV. Connect to it the same way you did above. Convert it from blob to raw. Bring that in. And then you're going to go through and you're going to perform the computations. Right. Beyond that, we'll get down to the bottom just like you've done in the previous two. Double click, add your conclusions in here. What'd you get out of this assignment? Which parts were the most fun, time consuming, enlightening, tedious? What really beat you up? If you had more time to go play with this and explore, what would you have done? Okay. As I said before, we've all got time constraints, and we go with what we've got available to us. If hypothetically you had more time available in the short term to do more in this, what would you do? What path would you go down? Okay. So the next parts of this are going to be covered in that second lecture video for stats. So I'll see you in that second lecture video for stats.